In this video, we're going to talk about angles and transversals. The big picture is parallel and perpendicular lines have different relationships. Several of them involve parallel lines being cut by a transversal, which forms congruent and complementary angles. Now, with this information, given a known angle, we can solve for unknown measurements. So here's the key terms. We have a set of lines. Let's say that these are the orange lines here. These two lines, these set of lines, are cut by a transversal, this green line. Now, the lines don't have to be parallel. They can be, but they don't have to be. So let's talk about some of the terms. The term interior is going to be thought of in between the two lines. So I'm going to come over here and I'm going to highlight the area between the two lines. That is the interior. The exterior area is the area on the outside of the orange lines. Okay, so when we're talking about angles, we're talking about either interior angles or exterior angles. All right, now the next thing we're going to talk about is the different types of angles. Corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Now, the corresponding angles are two angles that have corresponding positions. So let's take a look at this picture here first. It says the corresponding angles 5 and 7. All right, so over here on this picture, I've got corresponding angles 5. Notice it's on the upper exterior, and 7. They're in the same position. We've got 1 and 3 are corresponding angles. We can also say 6 and 8 are corresponding angles, and 2 and 4 are corresponding angles. All right, the next ones we're going to talk about, and clean this up. The next one we're going to talk about is alternate exterior angles. The alternate interior angles. The alternate interior angles would be these angles here. If you're looking at this picture here, it's 3 and 6, 2 and 7. So I've got 6 and 3, 2 and 7. Those are our alternate interior angles. So 6 and 3 are a pair, and 2 and 7 are a pair. Clean this up. Now, alternate interior angles, or alternate exterior angles, alternate exterior angles are two angles on the exterior, but on opposite sides of the transversal. So alternate exterior angles would be angles like 1 and 8, 4 and 5. So exterior angles would be 1 and 8, and then the pair 5 and 4. All right. Now, the last is consecutive interior angles. Two angles that are on the same side of the transversal and are on the interior of the two lines. These are also called the same side. So these would be 2 and 3. Those are consecutive interiors. And 6 and 7. This is following the same pattern here. Now, you also have, as we had talked previously, about adjacent angles and vertical angles. So adjacent angles are going to be the ones that have a same side. So you've got adjacent angles 3 and 4, and you've got adjacent angles 1 and 2. You can also have adjacent angles as 2 and 6, as long as they share the same side. All right? Now, undo this, clean this up. You also have what they call the vertical angles. Vertical angles are opposite the vertex. So you can have 1 and 6. You can have 5 and 2. You can have 3 and 8. And you can have 7, and 4. Those will be our vertical angles. Let me clean this up. Now, the next thing I want to talk about is the perpendicular transversal. It says, I'll go ahead and scroll this up. It says the perpendicular transversal is parallel lines cut by transversal perpendicular line. So if that is the hypothesis, then it says, all right, if these two orange lines, our sets of lines, are parallel to one another, and our transversal is perpendicular to the line, that means everything is 90 degrees. This is 90. This is 90. This is 90. This is 90. All right? So all the way around is 90 degrees where the two lines are cut by the transversal. So that's the perpendicular transversal. The next thing that we're going to talk about is parallel lines being cut by a transversal. So I'm going to move this down a little bit to give myself some room. And I'm going to create a transversal line that comes out like this. Now, well, I'll follow the pattern that this one has, just to keep it similar. The lines that are parallel do not have to be horizontal lines. They can be at an angle. They can have a slope to them, as long as they're parallel. Now, we have two parallel lines over here, and we're going to talk about the same types of angles we did before: corresponding, alternate interior, alternate exterior, and consecutive. We have the two parallel lines L and M. Now, the corresponding postulate says, or the rule says, if two parallel lines are cut by transversal, then the corresponding angles are congruent. That means the corresponding 2 and 6, the ones that are on the same position, that means 2 and 6, the angles here and here, have the same measure of degrees. That means the angles 4 and 8 have the same measure. This angle here, 1, has the same measure as 5. And this angle here, 3, has the same measure as 7. All right? Those are the corresponding angles. And the corresponding angles are congruent, meaning they're the same angle. Now, the second one says alternate interior angles theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. That means alternate interior. So we're talking about interior and we're talking about alternate sides. So we've got angle 4 is the same as angle 5. We've got angle 3 is the same as angle 6. All right, those are the alternate interior angles. Now, the next we're going to talk about is alternate exterior. If two parallel lines are cut by transversals, then the alternate exterior angles are congruent. That means 1 and 8 and 2 and 7. Those are the same. So 1, the angle at 1, is the same as the angle at 8. The angle at 2 is the same as the angle at 7. Remember that this is only going to work for parallel lines. Now, the last one has to say is the consecutive or the same side interior theorem is if two parallel lines cut by a transversal, then the consecutive interior are supplementary. Remember what we said about supplementary. Supplementary angles add up to be 180 degrees. So if I have this angle here, 4, and this angle here, 6, when we add the angle at 4 and we add the angle at 6, it's going to give us 180 degrees. And if we have 3 and 5, then when we add the angle at 3 and we add the angle at 5, we'll get 180 degrees. All right? Now, the remainder of the lesson has to do with angles and transversals of proving the theorems. So we're not going to go over that. So this is going to be the end of our lesson. You can read that in the notes.